I'm going to start with the slide that I just left off on because I wanted to then transition. So what we've got occurring here is now the genesis of what we understand to be the modern continents as we know them. We start to see North America start to emerge. We start to see Europe and Asia start to emerge. In fact, what we do know is Europe was its own continent and Asia was its own continent before they merged. And now we've got one large continent here post the breakup. So we're starting to see the creation of the Atlantic Ocean in this location. We're starting to see splitting taking place. It's sort of like as a zipper opens up. It opens up first here and then it opens as we move northwards. We're also seeing the opening up of the Southern Ocean as South America pulls away from Antarctica, Africa pulls away from Antarctica, and this big rift as India really moves out from Antarctica and off of Africa. We start to see the Southern Ocean appear. This is really critical because it starts to change the climate of our Earth, very much so, because we start to generate this very large water body down here. And if you remember, water has a huge capacity to store energy and to release energy. So we're going to create a southern hemisphere ocean down here, which is going to really change the characteristic of ocean currents and what becomes wet and what becomes dry. So if you'll indulge me, when these continents were closer together, pretend that this seam wasn't here on this large continent, we had a large volume of landmass here, which is going to be really hot and really dry because it's nowhere near an ocean mass. Now that we move Antarctica and South America and Africa away from each other, now these areas through here have greater access to water. As we later split South America from Africa, now we have both sides of this landmass has greater access to water, likewise with Africa. India now has greater access to water. Australia and Antarctica both will have greater access to water. And so this is going to furnish a greater opportunity for different plant and ecosystem structures to emerge. Prior to that, we had a nice moderate wet edge across all of this large landmass with a very dry center. Cold and dry up here, cold and dry down here, hot and dry right in here. So as we're splitting those early ocean masses, we have to remember that plate tectonics is not a done deal. The Earth is still moving, and we know it's still moving because it's undergoing earthquakes and volcanism currently. One of the places where there's active seafloor spreading is with the Red Sea, and the Red Sea is part of the Great African Rift Valley. And so we've got this, and we see Ethiopia and the Sudan here on this part of Africa with the Arabian Peninsula on the opposite side. It's a little upside down for us because note that the north arrow is pointing downward. So flip your perspective so it looks a little more familiar to you. So we're creating this rift through here, which is what we've got here, and it's going to split all the way down Africa into the Lake Victoria and then areas further south. So in this location, we started with a crack. That crack then moves in and becomes a series of lakes, and eventually those lakes start to infill with greater volume of water as the spreading continues. And we form a sea. The spreading is still continuing, and eventually the Red Sea is going to be an ocean, not any different than the Atlantic Ocean is. So with plate tectonics and watching currently places like the Red Sea start to emerge into larger bodies of water and push apart land masses, we start to recognize that evidence such as this and other bodies of evidence post-World War II and submarine evidence of mapping the Atlantic Ocean during World War II gave us the evidence that we needed to help support Alfred Wegener's theory of continental drift. And we move from just aimlessly drifting around to now a mechanism that affords us to understand why the continents are moving around the surface of the earth, which directions they're going, what the rates are that they're going. And that happened in the 50s and 60s once all that data was available and declassified after World War One. So the plate theory starts to begin, and we really recognize that the Earth is made up of two types of plates. And we mentioned those with the last series, module series, where we have continental plates, which is where you and I hang out. And then we've got ocean plates, which are the very dense batholithic rock at the bottom of ocean masses, or sea masses, if it will. So it's the internal forces from additional data that let us understand that convection currents, like the convection currents that we have in the atmosphere and that you saw in the last slide set, push up as hot mass rises, hits the underside of the continental plate or the ocean plate, and then creates a weak zone from that force, and then eventually those rise and push away from each other, carrying that rock with it, because that magma that's moved to the underside of the surface of the earth fuses to the surface of the earth, but the convective mechanism continues to rotate, and because it does, it drags and it pulls those continents apart as a result. This is a violent condition. It takes a lot of heat and energy in order to do this, and at these junctures, earthquakes and volcanic activity then are a mechanism and a byproduct of what's happening there. This whole convective current is what creates continents, but also what destroys continents. And it's we're subducting rock, we're thrusting rock, we're folding, we're faulting it, and essentially all of that is displacement. And that displacement comes hand in glove with volcanic activity to create these new land masses.